Hello everyone, Embedded Monkey here. It's day 20 of Embedded Adventure. Yep, where I am as a complete monkey trying to do different things with esp32. Yep. Um, by the way, today I'm recording in evening time, as you can see. It's like 5 p.m. almost. The reason is I had an exam and I actually failed it. Actually failed an exam, but okay, I will have another try next month, I guess, and I will prepare better. So, yeah. In previous series, what we have done was just exploring freertos in general, like how it works, what is like why to use it, and all that stuff. So I understand actually a lot of things in previous series, and the most important thing, we made a program. We made a program that simply has one task created, and this one task simply prints like a monkey name that is passed through params. Yep, yep. That was like a plan. Oh, by the way, yeah. Beside, like, outside the video, I just tried to ask ChatGPT to visualize like the task flow for me, but as you can see, it's not very accurate, I guess. It doesn't look very accurate for me, and not very good in general. The first illustration was just like, probably it's kind of like a state machine. Yeah, so that's like a different states of a task that actually exist in RTOS. So if we Google like RTOS task states, yeah, we'll get something similar. I actually haven't really explored like what all this means, what all these states means, but that's also interesting. Okay, so let's just continue, and I remind you guys, let's by the way flush the program that we have built in the previous video. And as far as I remember, we had a bug. We had a very awful bug there. One moment. Yep. Successfully connected. Yep. Let's just reproduce that bug and try to understand why it occurs. So again, yep, we're just creating the similar task and then simply deleting it. Yep. Well, it should actually work for some time, yep, but okay. Well, maybe we actually should wait. By the way, okay, let's just simply flash it. Okay. ID of that by, of course, com5, flash, and monitor. We're gonna see now how everything works. And as far as I remember, no compilation errors had occurred back yesterday. Yeah. Okay. Let's just wait for a bit. It shouldn't take a long time since it was built, actually. Yep. Okay, so we are flashing. And yeah, we're getting the guru meditation error. So I want to stop it. Yeah. Guru meditation error, exception wasn't handled. So let's explore it a little bit. I actually can't really understand what all of these mean. It's actually strange, but okay. Maybe here. So we get the PRV select highest priority task, then vtask switch context. actually a lot of different functions that was called here. And as you probably can remember if you watched previous series, I actually asked ChatGPT like, is this a task? And kinda yeah, but actually that function is basically should run inside the main task, and main task is created initially. Yep. So probably, you know what? I guess we and actually these functions should not have. Well, it can actually have the infinite loop, but the main thing is that tasks should have infinite loops inside. Why? Because the thing is that our task is acting like basically like a state machine, not state machine, but well, tasks are executed like permanently, and they are ended only when they are killed, like permanently killed, like with vtask delete or something like that. So when we completely destroy all the structures that are actually holding there, are held there. Yeah, so I just wonder what will happen if I just like wait for a couple of minutes, for a couple of milliseconds afterwards. So I created a task. Probably it should have some time to actually do some stuff. Probably, yeah. So vtask delay, let's imagine like we have something like 3 seconds, and within 3 seconds we should actually see this task running. Probably. It also waits, so let's check. I can't really remember why, but there was a very actually strange principle that works only in freertos. Let's check. I just can't like remember the actual thing why we put there the delay. One moment. Yeah, there was a quote by ChatGPT, by the master of embedded systems, that tasks should spend most of their time blocked, not running. And the thing is that in FreeRTOS, the efficiency is not dictated by CPU utilization, it's actually dictated by availability of every task. So different events trigger them. Yep, so that's why we put it here, and probably we should put the delay here to actually allow other tasks to work a little bit. Okay, let's flash it again. Build and flash, yeah, build and flash. Okay. And by the way, guys, while it's building, I just want to share like some emotions. Like I had an exam, I failed it. It's actually not the main exam. It was like the exam, the prior attempt to pass it, but I failed it, and now I have to go to like main pass. Okay, yep. So okay, I will finish a little bit. So yeah, I'm a little bit upset, but actually, it's not that disappointing, I guess. There are much worse things that can happen, that could have happened. It's actually don't stop. Okay, so yeah, a little bit upset, but everything's fine. Everything's fine, bro. Okay. So actually not, we don't get the actual results here. That's strange. That's strange. We actually can debug it in a monkey way, but I guess the actual thing is happening here. The actual thing is happening here, but I don't really know which part of code is wrong, because I can't see like the actual files here that I use in my program. Yeah. I could have Googled it, but this is a very common issue. Like, guru meditation error could have happened, like, for dozens of reasons, so probably I can't really rely on Google search output. Yep. Nor on GPT. Maybe I should not delete it, actually. But probably the problem is not here. Probably it's not here. Okay. Maybe the problem is with params that are actually that function takes. So let's just recall like which params does it take. Just want to start freertos. Yo, there is official documentation of freertos. Pretty cool. I actually was looking for the esp32 API, but interesting that they have the same API. Okay, x does create. I just wonder. Oh, here it is. Here it is. So we put. Sorry. Oh, okay. So we actually pass the task code, and the task code is basically the pointer to a function, or basically it's an address of a function. Yep. Then we pass the debug name of a task. Yep, we pass the debug name of a task. Then we pass the stack size, and the stack size is actually chosen in words. We chose it in words. Yep. The size of the task stack specified as the as the number of bytes, actually. That this differs from vanilla freertos. Interesting. So actually that thing is in bytes, not in words. That's interesting. Because ChatGPT said that I should specify number of words, and I just allocated only one byte of a stack. Not so cool. Not so cool. Okay. Then I just simply put params here, and I can't do that. It's absolutely illegal. So I just put the the address, the pointer, so I can actually access it. Create the task during the handle. Note that the pass parameter must exist for the lifetime of the task. So in this case, is declared static. If it was just an automatic stack variable, it might no longer exist. Static. By the way. Oh yeah, I guess I got it. I remember that static variables in C are just basically, they remember their state between different calls, so probably I'm right. Static variable in C function. Static variables in C. Yep, that's basically it. So, well, maybe I actually should make it static. Let's try, first of all. And the second one is what task idle priority. By the way, task idle priority. Okay, let's just pass task idle priority, let it be. I just don't remember why I put the 2 there. I just can't remember really. Then we put the address to handle. Yep, correct. And that's probably all that we have to do. And the stack, yeah. Let's ask, like, what's the minimum stack size, minimum stack size that can be created in task. The theoretical minimum and the practical minimum are very different, especially on esp32, let's be precise and honest. Theoretical minimum, from the freertos API point of view, is in words, not bytes. Actually, it's in bytes, not words. Yeah, so US stack depth, the size of the task stack specified as the number of bytes. Here it says words. So the minimum valid value is 1 word. Usable in practice. freertos actually puts on the stack. Okay, so we basically don't need anything in stack. We don't actually allocate anything there. Like, why would we use anything more than 1 word? Well, okay, of course it's in bytes actually, so we should specify the byte value. If I'm not mistaken, the word is actually 16. No, it's 16 bits. It's like 2 bytes. If I'm not mistaken, like word bytes. The word is natural data percent typically. No, 32-bit is actually double word. 16 is a word. Yep. So 2 bytes. Yep, so basically we should specify the 2 here. Let's just, well actually, let's see, is there a problem in priority? Yep, so we're gonna, what we have changed? We have changed the params to static variable, and we just put the bigger stack number there. So let's try and debug it again. Yep. Flash monitor. Okay. Well, actually, that's strange that they have such a difference in API, because I thought that, like, if you implement like freertos function, you probably should follow this API. Maybe they actually had some reason for putting here bytes and not words, interestingly, but okay. The same thing. Damn, please stop. Holy shit, it does not stop. It won't stop. I'm just spamming the, like, look. Damn. We can actually analyze the error here. I would like to actually be able to read all of that stuff. Core 1 register dump. Core 1 panicked, the exception wasn't handled. Task1.c. Bootloader. Actually, let's just see if it's the creation problem or is it just inside the task. Yep, so maybe it's inside the task. Like, task was created successfully. Yep. Let's just see if it was created. Yeah, if we could actually debug it in the proper way and not in Platformio, yeah. Not in that damn Platformio thing. I hate it. I still hate it. Okay, flush that thing. No. But let's see, does it actually output anything? Just spamming that thing. Okay. No, it actually can't really create the task, so the problem is actually in creation, not in the task itself. Yep. So task is not guilty in all that stuff. Let's just ask, you know. I just wonder what's wrong. Like, the clear explanation. Or actually, I have another theory. We wanted to try the task... No. Wanted to try task idle priority. Yeah, so let's try to put task idle priority. Because I have a suspicion that it can be the problem with the priority. If this task have like high priority, not the idle priority. Idle priority is probably the, as far as I remember, is the lowest one. So if it has like something above idle, probably other tasks can't really occupy any core to do some useful work like system tasks. So probably that can be the reason. That's why I want to actually make another experiment with that one. So I guess there are basically two reasons. Either priority or stack size are broken. Yep. Let's go. Another, oh shit. I almost dropped my esp32 now. But it's safe. It's safe. It's on my table. A little bit messy here, but okay. But yes, you can see it's here. Huh. So, was the task created? What? A Stack Overflow in Task Monkey name has been detected. Yo. Stack Overflow, bro. We should have allocated more. We should have allocated more. By the way, I understand why. I understand probably why. Damn. How can I kill that process? It does not, it's not killing. I can't kill it. Can't really kill it. I can't just close it. Damn. Okay, so finally some progress. We finally found something that was holding that guru meditation error. I don't know why they call it guru meditation error. That's like the dumbest naming I have ever heard, but okay. Yeah. By the way, it's not that annoying as segmentation fault, so yeah, I guess they just created an alternative for segmentation faults in esp32. Okay. Monkey toes. Let's see. Wait, what is the recommended stack size? Like, what does it store there? What should it store there? 256 words or 1024 bytes. Why? Why does it have a word? Like, wait a minute. What is the size of a word in ESP32. A word is 32 bits, one word is 4 bytes. That actually makes sense. So they have not double word equal to 32 bytes, but a word equal to 32 bytes. Oh, 32 bits, sorry, yeah, 32 bits, which is basically 4 bytes. That's why we actually allocated less than the actual size of a word. And probably the bare minimum, the lowest minimum possible that we should allocate is like 4 bytes for one word, actually. Because I want to actually see, like, I understand that, like, the more the better, yeah? But microcontroller has, like, small memory, yeah? So it's better to use it as minimal as possible. Let's try to compile it again. IDF.py com5 flash monitor. Damn, I should have told you. You know what? On today's exam, I had a question about interrupts, bro. I should have actually showed him the video of interrupts on ESP32. Yeah. The question actually was about MCS51 microcontroller. I can show you it. MCS51. Yeah. I actually know only that it has like 2 interrupt types, int 0 and int 1. But, yep. That's not how it works on the ESP32, so I would probably don't actually succeed with it. No, actually it's not enough. As we can see, it crashes. It completely crashes. We can see that, yep, stack overflow. Stack overflow. Okay, so one word is never enough. Probably, yep. So let's allocate absolute minimal task, like, let's locate 1024. 1024. I hope that would be enough. Like, 1024 is, if we divide it by 4, so 2 to the power of 10 divided by 2 to the power of 2, we get 2 to the power of 8. Now, which is 2056 words, which is absolute minimum. Let's try. I'm actually interested to find the minimum. Okay. Embedded adventure, yep. Monkey RTOS. Let's now compile it. Flash monitor, all that stuff. Cool. Yeah. Damn, I'm still upset a little bit. I don't know why. But I'm actually grateful that I'm recording that video. Oh, by the way, yeah. It's actually fixed it. Monkey name embedded. Finally, the task was called. Pretty cool. So, yeah, I guess that's it. That's actually it. So, it works. You know what? I wonder, what if we change the monkey name in the process? Like, say we created a task, we said the task was created successfully, and then we said, like, you know, fuck it, let's say that the params 0 value is like some different chars. Say it's like, I don't know, say it's G and like I wonder how it will hold the data race now. Yep, how it will hold the data race. That's interesting. Let's take a look. Oh, yep, completely forgot that. Yeah, just coded in Python a little bit too much. Sorry. Should code in Python less. It's too simple. No memory, no nothing. And slower, and 10 times slower. By the way, I wonder, can I program the ESP32 with Python? Interesting. ESP32 Python. MicroPython. What is it? Huh. What, one moment? Networking, I don't know. For real, I can program in Python for ESP32? Like here, connecting some things. No, let's DC. Yo. By the way, I should actually do some experiments with ADC. Or no. Actually covered that topic. But okay. Damn, we can actually do that in Python for an experience. Yeah. New theme for a video. Yeah, I will just write it to my plan. As you all know, I have a plan. By the way, you can all check it. Like, there's a link in the description always. Yeah, that's actually a good idea. I like it. Try to program all this, like not all the same stuff, but yeah. Let's say it will be like ADC, DC in MicroPython. I don't know why, but for some reason I like it. Seems pretty cool. Yeah. Okay. And by the way, we get some error here. Let's look. Again, it won't shut off. It won't shut off probably. Well, we can actually see what it tells us. Guru meditation error. Course you're panicked. Maybe it actually panics because we have a data race. Yep. Probably yep. It can actually panic because we have like the yeah, here, load store error. Like, okay, let's just kill it permanently. I'll just simply Google it. Load store error, ESP32. Load store error. The exception may happen in the following cases. If the application has attempted to do an 8 or 16-bit read to or write from a memory region which only supports 32-bit reads/writes, the referencing a char pointer to instruction memory will result in such an error. If the application has attempted to write to a read-only memory region such as well, it's definitely not read-only, it's just static. Yep. It's just static. Okay, so we could have actually replaced the 0th element of that char array to G. Yep. If the application has attempted to do an 8 or 16-bit read to or write from Actually sparse 32-bit reads writes. Huh. Well, probably it already tells us that it's not okay to write something that we are reading from the another place constantly. Maybe. But until we hit the vtask delay, we probably don't really allow this task to work. So when we call vtask delay, we basically block this task and say, hey, you can work. But here, it should not execute. That's actually strange. Maybe there more information here. Rows object detection. By the way, let's check the log again. Maybe it told us where do we have this error exactly. That's a good suggestion. freertos. Flash monitor. Again, yep, I just want to actually, well, we could have actually not flashed it, but okay, just to see where. So at freertos 24. Why? Like, can't we really? We can actually probably do that thing. It's not const. It's just simply a char. Okay, you know what? Let's say it is a static array. Maybe it's actually internally casts it to constant. So let's make it just how much letters? 1, 2, 3, 4, 5, 6, 7, 8. Perfect. 8 letters. And we just changed 0. Yep. And we actually nothing changed. Nothing changes. Everything's okay. Alright. Again, we just maybe I should reset it. It's actually not reset. It's still running. It's completely cooked. Okay, again. No, I actually don't like that monitor interface because it's just so annoying when it can't really stop. Just so annoying. Okay, just one more time try to debug it. Let's monitor. No more coffee. No way. And yep, it actually works. So probably the compiler just casted it to constant, I don't know, but it actually works. Yep. I understand, by the way, why we have here that symbols. We forgot to just 0 to terminate this string with a 0, but that's okay, that's not that serious error. Okay, fine, cool. So we actually made it. Yeah, we actually debugged the task. Yeah, finally it is created in a good way, so in a proper way. Yeah, finally, with a minimum stack size, with a good priority, everything's okay, and we actually made a little bit of data race. Well, I probably will do some more experiments in it in the next series, but bare minimum is ready. Cool, guys. So actually, in the beginning of this video, I was really upset because I failed my exam today, but that's so cool that I have this channel, guys. I don't know. I'm just so grateful. That's so cool. That I just, well, even when you feel bad, you just need to stay consistent, and first you do and then you feel, not you feel and then you do, right? So actually I'm actually happy now because I debugged my program, I recorded a video. That's so cool, guys. Thank you so much, guys, that you're watching me. I'm just very grateful. Thank you, guys. So if you enjoyed this video, like, subscribe, leave a comment. Next time, I guess we're gonna do more experience with data race, with like data conditions, all that stuff. I'm really curious. And I guess then in the next series, yeah. So the day after tomorrow, probably we'll do something like communication between tasks, because it's really cool. It's interesting. Yeah. So I hope you guys enjoy. Yeah. This was Embedded Monkey, Embedded Adventure Day 20. See you tomorrow. Bye.